Day 11 of 420 focused on comprehensions and generator expressions. The goal today was turning comprehensions and generator expressions into something I can explain from the code instead of memorizing from a tutorial. I did not want a lecture that only sounded smart on paper. I wanted a Python-specific model that would still hold up once the sample code turned into a real service, CLI, job runner, or library. The first concrete check was data shapes that stay obvious at a glance. That sounds small, but it decides whether the code reads like a contract or like a lucky pile of implementation details that only works while one person still remembers the original plan. The second check was control flow that makes valid states visible. That is where bugs usually start when the edge of the system is vague, because weak assumptions leak deeper into the code before anyone notices the meaning already drifted. The third check was small units of logic that remain easy to test. Once that part was visible, I could name the data shape and control flow before stacking shortcuts on top. That is the moment the topic stopped feeling like tutorial vocabulary and started feeling like reusable engineering judgment. The implementation only started to feel solid once I could keep I/O, state changes, and pure logic separated enough that one failing edge stays easy to locate. In Python, that usually means the runtime behavior, object boundaries, and error paths all need to agree about who owns each decision. I kept returning to one more rule: prefer explicit Python over clever compression when another engineer has to debug it tomorrow. That shortens debugging because the code tells you where to look instead of forcing you to reconstruct the intent from scratch after the wrong behavior already escaped. The predictable mistakes were letting convenience hide where state changes actually happen and writing Python that runs today but stops explaining itself the moment the next requirement lands. They look different on the surface, but both come from letting convenience win over clarity while the codebase is still small enough to hide the cost. So my recap for day 11 is simple: turning comprehensions and generator expressions into something I can explain from the code instead of memorizing from a tutorial. Keep data shapes that stay obvious at a glance, control flow that makes valid states visible, and small units of logic that remain easy to test visible, and the code stays much easier to test, explain, and change when tomorrow's requirement arrives. One reason I keep drilling these days is that production changes usually alter the surface area, not the core contract. If the contract is clear, the refactor stays local instead of infecting the whole project, and that is a much better place to be when release pressure shows up. That is especially true in Python, where convenience is powerful enough to hide weak ownership decisions for longer than you think. Clear boundaries keep that convenience useful instead of letting it blur the next debugging session. A lot of debugging time disappears when the request path, async path, or data path is obvious from the structure. The language and libraries help, but only if the design is honest and the boundary is visible in naming, types, and flow. My test is simple: could I explain this same design tomorrow with a different example and still keep the same reasoning? If yes, the lesson probably landed for real. If not, I probably memorized a recipe instead of understanding the trade-off. I also ask where the next teammate would hesitate. That question usually points at the first boundary that is still implied instead of stated, and cleaning that up early is almost always cheaper than doing it after two more features land on top of it. When the code is shaped well, the functions, classes, handlers, jobs, or migrations tell the same story. When they do not, the mismatch shows up in review before it shows up in production, which is exactly where I want the correction to happen. That is why I keep practicing with one concrete path at a time. A small path is enough to reveal whether I understand the design or only recognize the tooling around it, and that is a much better signal than just getting the sample app to run once.